Let's take up question number 7. It states that the opposite faces of dice X are these, where 5 is opposite to 2, 6 is opposite to 3 and 4 is opposite to 1. The opposite faces of dice Y are such that 3 is opposite to 5, 4 is opposite to 1 and 6 is opposite to 2. So further it states which figure can represent both dice X and dice Y with faces shown below. You can clearly observe I have 4 figures here and I need to obtain that figure which represents both dice X and dice Y, and through the given condition we get a clear idea. These are the opposite faces, they cannot be adjacent faces. So taking that into consideration, here if I consider this face, here 6 and 3 are adjacent, but when you observe dice X, 6 and 3 are opposite faces, they cannot be adjacent faces, so this case is cancelled. Coming to this one, here I have 2 and 6. 6 and 2 are opposite faces, they cannot be adjacent according to dice Y, so this case is also cancelled. While coming to this case, here I have 3 and 5 adjacent faces, which is clearly representing the opposite faces of dice Y, so this case is also cancelled. Here I need to consider a case which satisfies both the conditions of dice X as well as Y. 4 cannot be adjacent to 1 according to dice X. So clearly we do not have 1 as any of the adjacent faces. Moreover, it satisfies the condition for 2 and 3 because here 2 should be opposite to 5 and 3 should be opposite to 6 according to dice X. And here 2 is not having adjacent face as 6 and 3 is not having adjacent face as 5. So this validates the condition for both dice X and dice Y. That means here I get the clear answer that this dice C is the required dice according to this question. So the clear answer will be dice C, which is found in option number 3. So we write here answer for this question will be option number 3. I hope it is clear to you. Let's take up our next question. So here we have question number 8. It states that if I have this condition which represents a cryptarithm, that is, it is a puzzle where these alphabets represent the numbers which are added up to give you the resultant as 37,849. And it further states then find the code for this word having the alphabet TURNS from the given alternatives provided. There is no carrying over in the given addition using letter codes. So here each and every alphabet represents a specific, that is, different number. Taking that into consideration, here if I write that if this could be possible, alternative from the option, we will go by the options. So we need here sum of UTS as 9. So I need U plus T plus S equal to 9, and which of these satisfies that condition? If I take UTS 1 plus 3 plus 5, this gives me sum as 9, so this could be one of the probable option. Next here 6 plus 5, this becomes 11, so it is not possible. In this way, we cannot consider option number 2. Here 1 plus 6 plus 2, that is U plus T plus S is 9, so this could be also a probable option. Next 5 plus 3 plus 6, here clearly 8 plus 6 it will be 14, it will be not be 9, so this is also cancelled. Coming to the next criteria, T plus S plus T, that is 2T plus S is equal to 4. If I take that into consideration, 2T plus S, so 2 into 1, I get 2 plus 5, 7, so this is also not possible. Coming to option number 3, 2T, that is 2 into 1 it is 2, 2 plus 2 it is 4. So already 3 options are cancelled up, only one option left is there, that is option number 3. So the correct answer for this question will be option number 3. You can clearly mark your answer as option number 3, which will give you the correct code for turns. I hope it is clear to you. Let's take up our next question.